Hello, it's time for another Incus release, this time around Incus 6.3. I'm Stefan Greber, I'm one of the maintainers of Incus and the project leader of Linux containers. And yeah, this is going to be a deeper look into what's in Incus 6.3 and then trying to demo all of the new features. There is one rather massive, I guess, new features in there that a lot of people have been waiting for ever since I mentioned it back in February at a talk I gave at FOSDEM, and that's the support for OCI application containers. So up until now, Incus supported both system containers and virtual machines, both of which run full OS images that you then manage as like a stateful instance, and you can then use normal tools like Ansible, Terraform, whatever to manage those. With now having support for OCI images as well, it means you can start and mix and match both applications and full systems within the same Incus deployment. So that's the headline. That's what the screenshot shows, with it running a hello world from the Docker Hub image for it. All right, and the next feature we've got on the list is support for baseline CPU definitions in clusters. That's something that was a bit lacking ever since we got virtual machine support, especially once we added live migration support for them, because to try and get the maximum amount of performance, Incus always just passed through whatever the host CPU was into the VM, and that caused a number of issues when dealing with live migration. That's because even if you've got what you think are most identical servers, there might be some subtle differences in their firmware configuration that causes not exactly matching set of CPU flags, which then either causes the migration itself to fail or causes crashes once the migration is over. It also prevents having mixed clusters with a variety of different CPU vendors, or you just different models within the same CPU vendor. You're gonna have issues because then suddenly the VM would jump to a much newer, much older platform. Usually jumping to much newer should work, so long as they didn't remove any kind of CPU extensions, but moving something that's older is going to cause all kind of crashes and issues. So what we have now is kind of the first step towards really improving our live migration CPU type handling within clusters, and that's simply that we analyze all of the servers within the cluster for a given architecture, look at all of the CPU flags, and then compute what's common to all of them and expose only that to the VM. The VM then also sees a generic KVM type CPU. It doesn't know what actual CPU is being used. So that's what we've got at this stage, and again, we've got more work planned to add more flexibility around that in the future. The next feature is the support for io.bus and io.cache options for file systems. So both of those options were supported for disks within virtual machines, and that was letting you select, for example, whether you wanted a disk to be attached over Virtual SCSI, Virtual Block, and VME, and the cache option was then letting you choose whether to kind of take a risk by having caching in place and giving you much higher throughput inside the VM at the risk of consistency issues should the whole system die. On the file system front, the values are obviously a bit different because it doesn't work quite the same way. But on the io.bus side, you can now choose whether you want the default, which is using both 9p and VirtualUFS together, or forcing just use 9p or just VirtualUFS. And on the cache side, it actually controls caching options of io.bus, and it lets you decide whether you want it to start caching just the metadata or just effectively cache everything, which then gives you much better performance, but at the risk of some inconsistencies if that file system is also accessed by something else, which is pretty common. The next thing on the list are a number of improvements to incus-stop. So the incus-stop command was introduced in Incus 6.2, and it does pretty much what you would expect. It shows you a refreshing list of your running instances with some of the metrics. And that actually all relies on our internal metrics API, and lets you refresh that as often as about every 10 seconds. There were a few gaps in the initial implementation of incus-stop. It didn't let you run it against remote servers. It didn't understand clusters, it also didn't really handle projects all that right. So that's now all been fixed. It supports, you can use the normal syntax to deal with a remote server. If that server is a cluster, it will automatically go and fetch the list of all of the servers in a cluster and then query all of them automatically for you. That's because the metrics API on our side is not cluster-wide, it's per server. So if we didn't have that, then you would just see the data for the one server you happen to be talking to. So we handle that automatically now. Same thing for projects, where the project flag now works, so you can switch to whatever project you want, and you can use our old projects flag as well, which then shows you the table you're seeing here with all of the projects in there. The next thing is was actually a requirement for implementing the baseline CPU feature that I mentioned earlier. So we added to our internal resources API the CPU flags for every CPU core that we list. We do it per core because in some of the newer architectures, whether you're thinking, ARM Big Little or the new Intel chips with performance and efficiency cores, it's possible for different cores to have a different set of extensions. So this way we do actually get an accurate representation of that. And can actually, when calculating the baseline for a cluster, we can do it on whatever core type has the fewest extensions. So that's been added to the API that's internally used now for the baseline CPU calculation, but it's also something that others can consume if that's useful to them. Next up, we've got a improvement to incus-simplestreams, which is a new tool we introduced. I think it was Incus 6.1. I think it was 6.1. Maybe it was already in 6.0, I don't remember. But incus-simplestreams lets you effectively manage a static web server that offers incus images over while using the simplestreams index format and through the simplestreams protocol on our side. Up until now, it supported only split images, which is what we normally use for our public image servers. And split images means you've got two files. One is a metadata, usually a tarball, and the second file is the data itself, which can then be a tarball, squashfs, or a QCAT2 image for virtual machines. And that's what we do with the production image servers, because it lets us have the exact same metadata for both container and virtual machine images at the same time. But for those running their own image servers, and if those users are trying to publish an image that's extracted from Incus through Incus Publish, then that results in a unified image, which is a single tarball that includes both the metadata and the data, with the data being stored either as a directory for the case of containers, so it's a rootfs directory within that image, or as a file if it's a VM image. So in that case, I think it's like root.qcat2 or something like that. Effectively, it's a file that contains the disk image. And in that scenario, well, we didn't have any way to publish that, so that's now been added to incus-simplestreams through the add command. If you pass a single file, it expects it now to be a unified image, and we'll add it to the simplestream server for consumption by Incus. And lastly, wrapping up the transition to libovsdb. That's not something that should be really user visible, other than maybe having other networking be a bit faster, and especially a lot less spamming for the system log, because instead of running the oven tools every single time, which then need to go and hunt for whichever oven server is the current leader and then connect to that, we now have a persistent connection directly from incus to the database, the oven database servers, and can interact with them effectively immediately without having to go through that dance of figuring out who's the leader and everything every single time. It effectively eliminates all calls to those commands, so you can actually have a system without any of the OVS, VSCTL, oven, NBCTL, oven, SBCTL command. They're often useful to have around for debugging purposes. And it also makes it possible for interesting further work on the incus side, because now that we have that persistent connection to the database, it also means we get notified of any changes to those databases. So we'll be able to actually start reacting to anything external happening within Oven. Most commonly things like chassis coming in and out. So effectively physical machines coming in and out. We can now go and analyze those, see if they should be added as HA chassis on our Oven networks, which effectively means we will be able to add and remove servers that are not managed by incus from the networks that we manage within Oven. And that's going to be particularly useful once we start looking at supporting environments where you have dedicated machines to handle the Oven routing effectively. So in those cases, we'll be able to handle that this way. And that's it for Incus 6.3. So let's go into the terminal and start showing off those new features. Alright. Oopsie. Okay. I'm just gonna try and get this one out of here. There we go. Cool. So I'm just on my local system here with an empty project. And we're gonna start with well, the headline of this release, which is the support for running OCI images. So we do always call them OCI images because that's what they are these days. They're not. There's far more than just a Docker Hub, and that's been effectively standardized through the Open Container Initiative. But for the demo, we're just going to be interacting with the Docker Hub. So the first thing you need to do is actually adding a remote to talk to the image server, because there's quite a variety of registries for application containers. We're not going to be going we're not going to be pre-adding those remotes for you. But you can do it very easily. So in this case, we just want to add the Docker Hub. So we just say remote add, and then the protocol is OCI. Already happen to have it, so let's start that again. So add docker.io protocol OCI, you're done. And then if you just want kind of the basics, you can do docker hello world, because this is just like a one-time command that spits some stuff out. You should do console, and because we don't want to keep it around, we can do fmroll, so it gets deleted as soon as it's run. There you go. So we created a temporary instance called evolving tupper, run the command for that container, and then the container was immediately deleted, so there's nothing left behind. Next up, we can take a bit of a more complex example, which I'm actually going to copy paste from the announcement, just so I don't make any typos live here. And that's running, in this case, a MySQL server. So we're doing launch docker MySQL, and you can do the usual syntax on the Docker side to select specific tags if you want. So I'm just using the latest tags in all of those, but you can do that as usual. So MySQL, we're gonna be creating a database called WordPress with a user called WordPress and a password that's WordPress. Probably not recommended for production environment, but for this demo it's gonna be just fine. And it is complaining because I guess it didn't like the the multi-line syntax for some reason, even though that worked fine. It might be the forum that actually did something funky. Oh yeah, okay, I know why. It is instead in my copy paste. That's the issue. It copy pasted the quotation from the forum. Okay, so that's MySQL. We should see it running, and everything we can normally do with a normal container, we can do here. So we can get a shell inside it just fine with exec. We can go and we could list the processes if there was a command for it. That's going to be a bit of a theme, obviously, with application containers. A lot of things are just plain missing because they don't need them. We can see here that it's running MySQLD. Everything else works effectively as you would expect. You can set resource limits, you can all of that kind of stuff exactly as normal containers within Incus. So MySQL is running, and now let's try and do WordPress. So my copy paste is going to have the exact same problem as last time around. Yeah, let's see if I can go and manually, yeah, I can remove those. Okay, cool. So let's go and do that. And remove this one. So it effectively just says, use the WordPress Docker image, and then use the WordPress DB host. That IP address is most likely wrong. So let's go and fetch the current one. Here we go. Put that in there and go. Whoops. Here we go. Those went pretty quick because I already have those images. So the same image caching mechanism we normally have with Incus images also applies here. So if I go look at my images, we can see a bunch of Docker images stored there. It's a bit longer if you try something that is not already cached. So let's do, I don't know, caddy, for example, as a quick it's actually a smaller image, but we can see what it does. No, it's already in my image cache. Well, that's unfortunate. Okay, let's delete that. I guess what we could do is just delete the because I can't think of an easy Docker image right now other than that. So I'm just deleting the MySQL image. Obviously that doesn't impact anything that's running, it just deletes it from our image store. And then let's try Docker MySQL and do MySQL 1. There we go. So this time it actually goes through the whole dance. So it actually connects to the registry, looks up the image, retrieves the image itself. Once it's retrieved, it needs to unpack it to effectively merge all the layers together, and then it converts it into a functional Incus image, which then gets compressed and loaded into Incus. So that's what we're seeing it's do right now. We know it's about 160 megs, it's about to be done, and then it gets processed as a normal image within Incus. There we go. So that's what that looks like for the first time you're actually using an image from the Docker Hub in this case. Anyways, back to the example. We now have MySQL and WordPress both running. So let's go look at our WordPress server. Here. So I'm just going to be pasting this thing. There we go. And we've got the welcome to WordPress. Yeah. Okay. Here we go. All right. So it's fully installed now, and there we go. So that works perfectly fine. Obviously, I didn't actually pass in any disk devices to any of those containers. So persistent storage is currently part of the container itself. So if you go and want to update it to a newer image, you're going to lose that storage. So you need to make sure to actually pass additional disks, which is going to effectively is the equivalent to what you do with Docker, with actually mapping specific directories. So in our case, you would do that through a disk device. And same thing in this case, my containers happen to have like an IP address that's accessible over my whole network. If it's not the case for you, and you would have needed like a port mapping within Docker, then you used to use a proxy device on our side to do the same thing. But everything else effectively works. If you're used to doing this kind of stuff with incus, then it works the exact same way here. All right. So that's for the application container. The next one I've got is around the baseline CPU definition within clusters. So let's see, I should be able to use a test cluster I had on my laptop. Oh, great. Apparently I didn't log in a little while. I'm using OIDC for all of my systems here. So I just need to go ahead and log in. Actually, it shows. Oh, I think it's because I'm accessing the wrong system. Yeah, that's why. Because I'm actually trying to access my own system over OIDC, which works but doesn't have the VMs I want. Anyway, now I'm on the correct one. So let's just make sure the cluster is functional. It is, and see what we've got running on there. We do have one VM running. And let's go look at the VM config. So it does have migration stateful enabled, which is good. And if we go in there, it does have the virtual CPU effectively. So we can see it shows common KVM processor instead of actually showing the full CPU. So if we go and launch a normal VM, alongside this, I will be able to compare and just see what that looks like. So comparing the VM that has the migration stateful flag enabled to one that does not. Because we only really want to do that baseline CPU logic for VMs that may be live migrated. For anything else, it's still a better deal to straight up expose what's on the system. So if you start a VM and don't set migration stateful, it's still gonna expose the full CPU. So in this case, we can see AMD Ryzen 5, the exact CPU bits and everything. And that's basically how that works. There's no knobs, no configuration, no nothing at this point. Just on VM startup, it's going to use whatever set of CPU flags are shared with all other systems on the cluster. And if that then allows you to like migrate between different servers. Another thing there obviously is if you do enable migration stateful, but you're not in a clustered environment, then it's not going to do anything because it doesn't really need to. So just something to keep in mind there. All right, and next up we've got system support for IO.bus and IO Cache. So again, let's just get ourselves a quick VM here. So we'll do Ubuntu 24.4 v1. I don't have it on my desktop either, so I just need to download that real quick. Okay. Here we go, and we can do a few variations, I guess. So config device add v1. What can we share easily? Let's do etc. So etc default. So that's going to be a disk, and we just want the source path to be /etc, the path to be mount etc default. Okay. Then we can do etc over .ufs only. So that would be io.bus .ufs. We can do etc over 9p only. So the first two are going to effectively work the same way because my system can do both 9p and .ufs. So the default is going to do .ufs because that's faster. But now the 9p one will do only 9p. And we can do like an unsafe one for another example. So this one, if we do 9p, it's not really useful because 9p does not support that. So it needs to either be .ufs or just the default. So in this case, we can just do the default and do cache and just do unsafe. Okay, and start that. And we're going to have a VM with the exact same path being exposed a number of times with 30 different options. Yeah, Alright, that shouldn't take too long to boot up. Probably another few seconds. Okay, there we go. Okay, so if we go look at what's been mounted, we can see we've got 4 of them. You can't really tell whether there's different options on the caching side, because that's an option to virtualFS on the host side. But we can see that the 9p one is mounted as 9p, whilst everything else ends up being virtualFS. And they're all gonna show the same thing, which is my /etc directory. Now, if we go look here for virtualFS, the v1, we can see that the cache it's running a few different daemons there for the different mounts. Let me see if I think the process tree is kind of messing with us. There we go. That's clearer. So we can see the default is just cache never, which is our default value. Same thing for the one that supports that's in auto mode, that's in virtualFS only mode, does the same thing. And then the one that's unsafe shows cache always. So that's effectively what that does. Now, for the next one, I should switch to a project that's maybe a bit, well, I guess we can do the basic incus-stop here. So next one is the improvements to incus-stop. So we can see here that it's running with just within that project, and it shows both our application containers and our virtual machine. Nothing particularly new in that regard. Now, if we switch to our default project and we start doing all projects, then that gets a bit more interesting because it does show the cross-project view of everything. My servers are not running on 6.3 yet, but there's a good chance it will still work because I think I cherry-picked some of those fixes. So if I connect to a remote server, yeah, that does work. Okay, cool. So this is a cluster in this case, so it's actually doing that request across multiple machines and then compiling the result as we're seeing it here. Let's see, all projects, what that does. Yeah, so I think there's still an issue if we're not in the default project for some reason. Need to look into what's going on there, but if we switch to the default project and then do it again, there we go. Now we've got the issue that we actually have too many things to show. Incus-stop doesn't currently have a good way to scroll or do any kind of pagination, so you need to just change the font size, which in this case makes it pretty small. So that's what's going on here with a clustered environment. And I should also be able to do, say, on my laptop. So that's another case of just accessing a remote server. We can see those 3 VMs that I use for the test cluster. They've been running a while. They've used a lot of CPUs, whereas like a normal container uses close to nothing. All right, and that's it for incus-stop. Next is the support for the CPU flags in the resources API. Because those are quite verbose and also not useful to most users, we didn't add them to the normal resources output because that was just too much to put in there. But you can always query the full data over the API. So it's like /1.0 resources. And then if you list that, you get the different sockets, and for each core, you get the rather long list of CPU flags. So that's where you can find that new information. It's also interesting to know that the resources API is exposed to our scheduler scriptlet. So if you know that a particular workload works better on servers that support, I don't know, AVX 512 or something, now you can do that. So you can mark the instance being placed somehow with a, probably with a user config key. And then once you put that user config key, then you can check that within the scheduler scriptlet and then look at servers that support the CPU extension that you want. So that can be a very, very powerful tool to actually better place both your containers and virtual machines onto systems that support the best CPU extensions for that. Next up is support for incus-simplestreams with unified images. So I guess we can just try and do a quick web server. So incus-simplestreams is a pretty simple command that can just import images directly and then generates the tree that's needed for static web server. So in this case, we don't really have any good candidate. Well, I guess I can export my speed test container, because why not? So let's publish actually speed test. Oh yeah, it needs to be stopped. Okay, that's fine. Let's stop speed test. Publish it. So it's turning it into one of those unified images. It's a pretty simple Ubuntu container, just with some tools to do internet speed testing. So it shouldn't be huge. It's actually larger than I expected, to be fair. And once we've got that, we can export the image, which will get us that single file, and then we can import that inside of SimpleStreams. I think the reason why it's so huge is simply because I've had that one running for so long that it's just been piling up updates effectively. So if we export the image, there we go. We've got our image 226 megs, and then incus-simplestreams add over that image. Okay, that worked fine. I can delete the image file from here, and if we look at the Filesystem tree now, it's just imported it in there. We can probably go and look at the JSON output for that, for anyone wondering. And it shows a single entry. It shows it as the file type, which is incus combined, and that's what we use to represent any of those kind of unified images. If we just want to compare that to like a regular split image, we can export another image, say Debian Trixie here. Okay. Which is going to come as two different files, and then incus-simplestreams add, and then you need metadata first, data second, like that. Okay. And why is it not happy? Okay, I did not expect that to fail. I'm not sure why it failed with this one. Gonna have to look into that one. But that's effectively the way this works now, where you can mix and match both unified and split images within the same server, and Incus is then able to consume those images, making it easier to publish your own images. And that's effectively it, because the last entry on the changelog is the transient to libovsdb from calling the oven tools, but this is effectively hidden from you. You're never gonna see it. The only case where you can really see what happens is by looking at your system log, or by looking at somewhere for a tool like forkstat to notice all of the subcommands being run by Incus when using oven. And if you ever did that, you probably noticed that like for every single instance, start, stop, creation, or anything, we were calling oven tools dozens of times because we have to create a lot of different objects and put a lot of things in place. Now you're not going to see any of that because we can just do the database change directly, and that's going to save a bunch of CPU time. It's going to save a bunch of time as well, like not just CPU time, but also like CPU consumption, but also the time it takes, because we don't need to go and figure out what server to talk to, which also means going to be reducing the load on Oven itself, because up till now, for every single thing we would try to connect to, if we weren't lucky and the first server we tried to talk to was already the leader, every single time it would then be talking to the wrong server, which causes CPU load on that server, and then connect to the other one, which gets even worse once you start doing encrypted Oven with TLS, because now you've got to do TLS handshakes all the time as well. So that should be a nice improvement. Probably, like, CPU usage is probably not noticeable on busy systems, but the time improvement likely will. And for me, the reduction in log entries in the system log is going to be quite useful, because now we're only going to be seeing log entries when something actually goes wrong, instead of seeing all of those tools constantly running and failing to find the right server immediately and having to bounce and reconnect to the right one. So that's it for 6.3. Obviously, the headline is really, we can run application containers now. So I suspect a bunch of people that might have been running Incus and Docker side by side might now look at, okay, what do I do with Docker if it's just a few applications? Maybe it should be just running on Incus. And same thing for anyone who's been running Docker inside of an Incus container, to then just run like a couple of things in there. You can just start and do that natively instead of Incus now. That's not to say that we are supporting everything that Docker does. We're not, and we're also not really planning to. We really want to focus on the most common cases that our users care about, and we're going to be looking at the initial feedback to see what we're going to be working on next there. Thanks a lot for watching this one. If you want to try it for yourself, you can go and do it on the online demo. We've even enabled the Docker, like the OCI container logic in the online demo. This might break because it relies on the Docker Hub, Docker registry, and all of those not changing IP address. And I don't know how often they rotate the IP addresses. So we'll try to keep an eye on it. It might break, but last I tried it was working. So let's see. Docker IO, protocol OCI, okay. And then Docker hello world, we want to see the console and ephemeral. Okay, it looks like it's still working, so it does reach out to the Docker Hub and runs the command just fine. So it currently works. Hopefully it keeps working. It's because the online demo environment has an extremely tight network restriction in place. Otherwise, we've got people running miners and running like attempting to spam people and do all kind of bad things. So we only allow connections to very, very specific servers. I extended that list yesterday to include the Docker Hub, but because it's all running on cloud CDN type platforms, those IP addresses are very likely to change over time. And so we're gonna have to kind of keep an eye on that and update them as that happens. Anyway, that's Incus 6.3. Thanks a lot for watching. If you've got any questions, leave them down below. Go on our community forum. Hope you enjoy it, and I'll see you in the next one. Bye.